Hi, I'm Snow. Today I'm going to solve another problem with LRU cache. The problem is pretty complicated to explain, so okay, here is a full description of the problem. Design a data structure that follows the constraints of a least recently used cache. Implement the cache class so that the LRU cache initialize the LRU cache with a positive size capacity, and for the get method, return the value of the key if the key exists. Otherwise, return -1. And for the put, so we are given a key and a value. We should update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of key exceeds the capacity from this operation, evict the least recently used key. The functions get and put must each run in O1 average time complexity. Okay, and here is an example. Okay, so in this example, the capacity is 2. And they put in 1, 1, and they put in 2, 1. So now the capacity is already full. And to get, it's just you want to pick the value of this key so it doesn't evict it. And then you want to put in another pair, but it's already full. So you have to evict the least recently used, which is 1 here. So we will evict this pair. And then we want to get 2. So 2 is still in the cache. We can return its value. And then we want to put in 4. No, wait a minute. So when we get 2, let me see. Oh, 2 is not there. So why? Cache is 1, 1, 2, return 1. LRU key was 2. Okay, so because you have inquired what is the 1's value, so this get method is considered using this cache. So once you run the get, you should put 1 to the recently used end. So this one becomes used. So when you want to put, you have to evict 2 because 2 was not recently used. We used it earlier. Okay, so the important thing is to remember that a get, both get and put, will be considered using this cache. Okay, now let's run another example to think through this problem. So I think capacity 2 is too short. Let's make it 3. Okay, so I want to draw a cache of 3. So when we put in 1 and 2, so those are key value pairs. And when we want to put in 4, this is full, so we need to evict this one. And we can, so this one is gone. And we have the capacity to put in a 4. Uh, okay, and I feel like this is like a first in, first out. So if you don't touch, you don't use a get or put for one, then it is for the natural order. If you don't touch any of them by getting them or by getting something like inquire their value, then the first in is the first out, right? Like if we put in a 5, then we need to evict the first in this cache. So it's like a DQ. Imagine this is a queue, so it's first in, first out. We can put 5 here. Okay, and what else do we need? Okay, let's see. So capacity and return the value of the key if the key exists. So we need to look up the value of a certain key. So that means we need a dictionary or map. Depends on what language you use. And update the value of the key if the key exists. Yeah, so that is also lookup and dictionary. Otherwise, add the key value pair to the cache. Okay, you can add this in a dictionary. If the number of keys exists, the capacity from this operation. Evict the least recently used key. So you need to evict an item from this dictionary, and the location of the item matters. So you must keep a record of the location or the order of the dictionary to find like who is at the start of the dictionary now. But okay, so and it says the get and put is constant time. So get is just look up constant time dictionary. Okay, no problem. And put, okay, the put is also okay. It's just we have to move this keyword pair to the end sometimes from the middle, because if we want inquire the value of 3, so the key 3, then we want to get this. So after we use get, we have to put it to the end of this dictionary. So we need an order for the dictionary, and there is a built-in class is order dictionary. So I think that's perfect for this problem. Okay, the order dictionary has a function to pop from either end of this dictionary. So we can use a pop from here, and it can also move a certain item to the end of the dictionary. Okay, so I'm not sure if we are allowed to use this order dictionary. If not, then we need to write our own order dictionary. So order dictionary, so we see we can pop something out and get it out to the end and insert it to the end. So we need a data structure to remove and insert using constant time. So that means it is a doubly linked list. Doubly linked list. So we will need to implement our own doubly linked list. So this becomes like a data structure with a doubly linked list and just a common normal dictionary. So it will be like, let's draw just a dictionary first. So the size of the dictionary is the same as the cache because we only need to store the key and value of what's already in the cache. If the cache is full and we want to evict something, we will also remove the key value pairs from this dictionary. So let's see, this is a dictionary. And now, like originally we have 1, 2, 3. And this is our key. And the value is a node in the doubly linked list. We use a doubly linked list to maintain an order of the nodes and also delete, remove, and insert the nodes in constant time. So I mean, in my brain, it's kind of look like this. So we have a dictionary to be able to find our keys, and the no for. So we wanna okay. So let's write it apart. The problem is, what is the value? So what should we put into the value? Sorry. Value. So we need to know if it is a linked list. We need to store the previous and the next. And we also need what data do we need here? So we can have two data here. One is a key and one is value. So the node will have 4 elements in this: the key, the value, the reference to a previous node, and the reference to the next node. And we want to just store this node in the dictionary. Because if we only store the value in the dictionary, then if we want to remove a pair, then we still need to, we cannot find what is its previous and what is next. So we won't be able to remove it from the linked list. So once we locate a key, for example, we want to evict this one with a 2 as its key, we need to know the whole information about this node. what is its previous and what is next, and what is its value. So we want to store this whole thing here. Okay, so the dictionary is, so the key is 1, 2. In the dictionary, we map key to the node. It's like a reference to the where the actual node is. Okay, so now let's write. Okay, shall we write the order dictionary method or the doubly linked one? I'm going to write both. So first, if we can use order dictionary, then we should. Okay, that's no, class. So I want to implement something. It's a class. LRU cache. LRU cache and constructor always self. And we need so this cache should have a dictionary. It also has capacity. And it also has a double linked list. So we need nodes. So let's write another class. In a node, there are 4 things. Yeah, for node, we need to know what is its key and value. Okay, so now we can have 2 dummy nodes. One is a dummy head, the other is a dummy tail. And we are going to put in things from the tail, and the head will be evicted once the cache is full. So how to write a dummy node? So dummy node is a node with no data. So just a node with no data. So we can make none here. So no key, no value, but it has the previous and next. Okay, and self.tail is the same. So it's the same, so I'm just use this. And now we need, I want to write a comment here. Dummy head and tail. Elect from head part, like head side. Okay. So that's a constructor. Now let's write the functions. We need a get. To get, we need to know what key we need to the key. So sorry. What I'm writing here. I'm writing this double linked list version. So it's not the order dictionary version. Okay, I will write the order dictionary version after this double linked list version. So this dictionary is just an ordinary dictionary, not an order dictionary. And yeah, everything's good. So get. Let's write a get. So we need to check if the key is in. If key is not in. If key not in dictionary, then we return -1. So else, and that means it's in the dictionary, then we can look it up. So the value is self.dictionary key. So we should return this one. Okay. But don't forget that we need to move it to the tail because we used it. Okay. So we need to do this before return. If we return first, then it will not be executed. Move it to tail. So move it to tail. So first we need to make it a node. A new node. It's not a new node. It's just it is kind of a new node, but we'll just write node is it. We need this constructor, and the key is the same key, and the value is value. Oh, wait a minute. So the self.key is a node. Is it a node already? Okay, yeah, it is already a node. because when we put this into our dictionary, we already wrap it into a node. So this one is not value, but a node has a value. So this is the value. It's a value. And we can just move it. We don't need to wrap it in a node. It's already a node. Yeah, we should have write the put first to make it more obvious. So let's write the put self key value. Okay, and we will make a new node. And we need to put this new node into the tail. Oh, first let's check if the capacity is full. Sorry, for put, then for put, update the value of the key exists. Okay, let's do this first. Update the key if it exists. If key in dictionary, update the key. Update the value of the key. Okay. So we need to update the dictionary. Dictionary key equals to value. Otherwise, add the key value pair to the cache. So we have modified the dictionary. And once we modify this, we should also consider it used and put this node into the end. To put a node into the end, first we need to have a node to the key value. So we're going to make a new node. Node key value. And we should put it to the end. So I'm going to write another function to put it to the end. For now, let's just imagine we have this function. So self dot move to end. No. So first we need to take it out of the list, then put it to the end. So we need to remove it. Oh, so let's write oh. So let's just write how to remove a node from doubly linked list. Let me draw something here. So from a doubly linked list, we want to remove this one, and we just need to link this. Okay, and this one got disappeared because we have this new link here, and this one is removed because we have this new one here. So this node in the middle will lose reference to it, and it will be garbage collected later. And we don't need to worry if it is removed from the head or the middle, because we already have a dummy node. So no edge case should be considered. So let's just write this and remove next node. So we know node, and so we know the node previous. And now it's going to point to the node next. And the node next. Previous is node previous. Since we still have this pointers, it's okay to just write this. Cool. So we can use this remove now. Remove this new node. And we need to put it into the end. So I will write another function called add to end. Okay, now let's draw another picture to see how to move this to the end. So we already have a dummy tail here, and our real end is this one. So this is a last node. We want to add another node in between of them. So we can do this and this, and then this and this. Okay. So first, let's see. Last node is dummy tails previous. And now we want the new node, the node to last node down next is changed to point to the new node, and the dummy tail next. The previous is our node. Okay, so we add it to the end. Okay, then we're done here. So that is the case if key is already in the dictionary. If not, let's check if the capacity is full. If capacity so capacity equal to the length of this dictionary, that means it's full and we need to remove the first node. Okay, which node shall we remove? It's the first node. And what is the first node? It heads next. So head dot next. This is the first node. And we also need to, so it's removed. We need to update the dictionary. Dictionary key. The key. So we're going to use this one again. So why not we just put it into a variable. So let's call it first node. So we want to delete this key in the dictionary. And to do that, we need to put the first node, the key. Okay. And that's it. And else, if it's not full, then means we need to, oh, not yet. So we have removed the first node. And now we need to add the new node. So whether the capacity is full, we will finally need to add the new node. So you don't need to else, we just write it here after this if condition. add new node. That means we add it to the end. Can call this function again. And we also need to add it in our dictionary. So self.dictionary new node key is, so new node, the key is just the key here. Don't need this value. No. So the value is a node. So this is a new node. But this one looks weird now. If key in dictionary, self.dictionary. Oh. We want to update the node's value. So if we write this new node, so that means then the previous and next of the new node will also be this value, and the old, previous, and next pointers are lost. Does it matter? Doesn't really matter because we're going to remove it anyway. What are we doing here? If key and update, okay. So if key in dictionary, we don't have this new node yet. It's declared here. We can update it after we move it. Self.add to end. Yeah. So let's update our dictionary now. So the first is to check if the key already exists. If not, check capacity. After checking capacity, we always add this new node to the end. Okay, that's good. Now the next step is otherwise add the key value pair to the cache if the number is, yeah, we have done this. Now let's complete our get. Kinanden self, the type of the next one. So that means if the key is in the dictionary, then we just get its value. Yes. And then we need to move it to the tail. We have a function evict, remove, and add to end. Remove this node and add it to the end. Okay, it looks a little bit repetition, so let's see. Let's got a node. So do I need to do anything to the dictionary? No, because we are just getting the value. We did not just change the location of this node. It's not deleted out of our cache. Yeah, I think that's it. Oh, finally, yeah. Now let's write a cleaner code using the other dictionary. Yes, so we don't need this node class. We still need this this one. We need a dictionary, a capacity, but we don't need this dummy nodes. And next, no helper function because we're not modifying the linked list. All of these are for the linked list. And we need to put something in. We just copy all of this and hey, doesn't work. Oh, just let me write it again then. Key value, when we put it in, we want to check if it is already exists. So if some of the dictionary key already exists, not key in dictionary, then we should update the value. So we don't have a node anymore. We can just update the value now. Yeah. So self that dictionary key is a new value now. That's it. And else, that means we don't have the key in the dictionary, so we need to put it into the dictionary. And before that, we need to check the capacity. If capacity evict. So we want to evict this key value pair. And for that, we have a built-in function called pop item. So no, I need to make this an ordered dictionary. So it's from, let's import it. Now our dictionary is super cool. It has an order. So we can pop the item from the start. So to do that, you should like start is start is true. What is the syntax? So the problem of it using a built-in thing is that you need to remember its syntax. I don't remember it. Let me check. So item last. Okay. So that we need to say last is true or false. The default is true. So it's like the stack, but we want to add it when we want to pop from left, so like a queue. So we need to say start is false. Okay, yeah, we just pop it out. It's thrown away. And now we can add our new node. That means we add another key value pair into the dictionary. That's easy. So self that dictionary key equal to value. Okay, that's our code. And next, the get. To get, you need to know a key. And to get, you also need to check if key in dictionary. If key is in dictionary, then we need to just get its value, and we need to move it to the end. To move it to the end, we can use self.dic. The order dictionary has a move to end function, and we just use this, and we need to specify the key. Okay, we move it to the end now, and we also need to return its value. Okay. So else, that means we can return -1. Okay, that's it. It's much simpler than this long code, but it really depends if the interviewer wants you to use the double linked list or not. Okay, bye-bye. Here.